Hello and welcome to another experiment. Today we are going to cover the gas calorimeter experiment, which is one of the mechanical engineering thermodynamics experiments. Sometimes following up with the different readings, writing them in the right places in your result sheet might be tricky. So I'm going to guide you through that, and I'm going to show you parts of the experiment which might not see during the normal lab due to the scheduled I'll brief you quickly on what we are doing here. Gas here. This is the storage of our gas, and basically we would like to know the calorific value of that gas. What we are going to do here, we are going to burn part of that gas and try to heat a certain amount or certain volume of water from temperature, inlet temperature to outlet temperature. So basically we can know this much of gas heated this much of water from, let's say, 20 degrees to 40 degrees. Okay? Now, provided other information to you, you can calculate the calorific value of that gas. So this setup in here, we call it the calorimeter, this part in there, which is the gas calorimeter. And this is here, gas is the volume meter. This tells us how much volume of gas we are burning. And the gas storage in the tank back there. And we got thermometers for water and gas, which we will cover them separately one by one. And we got a pressure meter in here, which tells us the gas pressure before it goes to the burner. So we will be dealing with gas volume, water volume. We will need time to get flow rates of both, and we are going to get temperature from different places on the system. The result sheet of this experiment looks something like that. Now, I think you will need to have this open in your computer or have a printout nearby you while we are talking about all these, so you can just follow up with me wherever I go and on the different readings. So first thing we will do here, we are going to get the setup ready. The burners of the gas is inside the calorimeter. In order to fire them up, we'll need to open this part up, fire it up, and put it back again. And this is specific part you don't see normally in the labs, because before you come, we switch this experiment on, get the water heats up for a certain temperature, then you comes in to make your time here is mainly for taking measurements, okay? So now I'm going to take this apart in order to get to the burners. Now this part here holds the coil inside where the water gets in from here. Go inside, and there is coils, turns of coils, and the water leaves from here. So water comes here from the tap. I'll tell you what is this device later in here, but this water is supplied directly from the tap, so it will come around room temperature. It will get heated up. Now these thermometers got different scales, so levels might be tricky. Like you can see the mercury level in here there, while it is in here there, but the temperature is almost the same because the device is not working as of now, because the scale of this thermometer is different than the scale there. So read the thermometers carefully and look for the mercury level and read it, not just assume based on the level. So in order to fire this up, I'm going to take this part up. Now if you are doing this or removing that, which you should not really do, you should take care of all the thermometers. These are all glass mercury thermometers. They can break easily if they hit anywhere. So whenever we are moving them around, we need to be really careful. And all this should be precise and very slow movement, especially when we are putting it back, because if we put them fast, this is like there is a high chance we extinguish the fire and we'll need to fire it again. So I'm getting this up now. Before I put it down, I would like to show you the coils. So down there, if you look into there, you can find a set of coils, which might look white color now. So these are the coils. The burners are in the middle, which they got the heat and heat the water while we are doing the experiment. Now we'll need to get this all down and settle in some secure place. I'm going to keep it here now. Okay. So now this one is on the table. We should be careful of all these hoses, pipes, and the thermometers. Now, if we take this part, this is basically where we keep the calorimeter in, and this is insulated, so this area inside will be hot, heating the coil which we just saw, and having the burners in the middle. So these are the burners in here, and we are going to light them up. Before going into there, I'd like to show you something in here. Now, if you look to this part, you might notice this pipe in here, which is having a hole inside there. This is to collect the condensate water. Condensate water is a part of your result sheet, and we would need to know the volume of the condensate water we are collecting. However, in some experiment runs, and if the experiment is not running for enough time, you might not get any condensate water. And in your sheet, there is some instructions to tell you what to do if you don't have condensate water. So now I'm going to switch the gas on, get these burners running, and get everything back to start with the experiment. Now this should be on in here. This is off, this is on. This is, see, now we need to follow the gas just to show you what all these pipes for. So the gas is stored in this tank at very high pressure. It's almost liquid. If you move this, you can see a liquid gas moving in. And this goes through this hose to this pressure reduction valve. So this valve, something we cannot really change or we don't use in the experiment. This is mainly to reduce the pressure from very high pressure in the tank to very low pressure, which goes to the burners. So this goes to this pressure reduction valve, then we got a couple of turns and get inside to here. As it goes inside there, this is called a water gas flow meter. Why we call it water gas flow meter? Because there is basically water inside this, and there is a specific water level which we can see. There is a water level. So this is, let's say, filled with water till this level here, filled with water till this level, and there are big buckets inside. So as the gas moves in, fill the buckets, push them, and keep them moving to leave from here. So the gas enter from top out there, push the buckets to turn down and leave from here. The water inside will hold the gas from escaping or leaking inside the flow meter, and only goes to one direction and leave from here. So as the gas flow, this will keep turning and turning and turning, and we will come into how to get a reading from this. Here we are reading the temperature of the gas, which is in our case is going pretty much the same as the room temperature, because the gas is stored indoor. In some places where the gas is stored outdoor or somewhere else, this temperature may be different than the room temperature. This valve here is going to control the gas flow to the burners. You can see this white hose goes directly to the burners there. While we are passing gas there, we are reading the pressure. This pressure will give us indication on the flow rate. So I'm going to open this little bit, and you can see here this meter is moving. You can see the meter is moving, and you might hear the gas is flowing in there. Now as I open this changed And you can see the flow meter in there start turning also. You can see it's turning slowly because the gas is trying to push it and leaves to the burner. Now I'm going to close this valve to light up. I'm using this torch here to start the fire, which is a bit easy way to than compared to the lighters, because sometimes the gas takes some time to reach there. And all these hoses, if we are not using the experiment, is filled with air now. We'll reduce this, is just to fire up. And we'll open this valve slowly. You can see now the burners are running. Okay, now you can see the burners burning very nice blue flame. These burners are labeled. You can see a label down there. We can change the burners based on the gas. Now this is one of the parts which you don't really see every time we run this experiment. Now if you keep looking to the burner, I'm going to change the valve here and you can see how the flame is changing. So as I change the flow of gas here, you can see the flame is changing. Now always we start with very low flame. We keep the pressure here for about 2 millibars, which is the red scale inside. We can see millibar and red in here. And if we look to the red scale, we are at about 2 millibars. This is a good start, and we are going to talk about how to change this and when to change it. So now the flame is on. Sometimes I will need to give it a few seconds for the burner to heat up, and then we'll need to get everything back to there again. But now this all should be very slow to avoid extinguishing this burners in there. So till now the burner is going and it's producing a lot of heat. We'll need to get this back in. This is a tricky part and will be going very slowly. We'll need to spend some time in this part, because if we go very fast, then we'll need to remove everything out and start this fire again. Okay, almost there. Okay, so it's in place. We'll need to get water flowing now quickly because the coil is heating up. So I'm going to turn the water from here. This again should be very fast. And the water will go up to there. That device there is going to keep constant flow of water to the calorimeter. You can see it has the 3 pipes going. The main pipe from the tap, which I just opened. Another one goes to the calorimeter, give a fixed flow here. So this is the water inlet. Then it turns in the coils which you just saw and leaves from here. So this is the water outlet. The third hose here, it drains any overflowing or extra water which we don't need. So if you look to this water here, you can see is almost at a certain flow rate and is not changing. And this water now, you can do 2 options on this. Either flowing through this hose and leaves and drain out here. So this is, we are just draining it out. This water we don't need and doesn't relate to our experiment. When we start collecting water, we are going to change this setting here. We'll just move this and we are going to start collecting water here. So now we have gas flowing and burning, we have water flowing. We can have a look into the different readings changes and explaining to you before we start with the actual readings. So now if we look into this thermometer here, I can read about 24 degrees. So this is the water inlet temperature. It's about here. And this is the outlet, which is reading now about 35. So basically there is a change of temperature of like about 10 degrees at the moment, and this is rising. It might not be clear in this video, but if you come to the lab, I'm sure you will see it clearly. Now this third thermometer here is reading the exhaust temperature. As the burners burn, heat the coil inside, the exhaust gas leave from these holes into. So we are placed this thermometer to give us the exhaust temperature. Now we don't need to collect water at this point, so we'll just drain it out and look into the result sheet. This is the typical result sheets. Normally during this lab we do two tests. 2 times repeating this test with different flow rates. So test will be test number 1. Ambient temperature, you can consider the gas temperature as the ambient temperature, as we said before, because the gas stored in-house. So this is about 24 degrees. Then come into this parts here. Now it's divided into 3 main parts, which is gas, cooling water, and condensate. Now while I'm reading this, as I told you before, I prefer that you have this page open in your computer or printout. I'm going to show you here where is every one of these parameters, but you need to have the table in front of you so you can follow up with me. So the first part is about gas, and this is volume of gas. So we'll need to get volume of gas. The volume of gas is coming from this flow meter in here, and this is 1/12 cubic foot divided into 100 parts. What does that mean? That means if we consider this is 0 and a full turn is 100, okay, so if this gauge make a full turn with 100 divisions, means that we burned 1/12 cubic foot of gas. Now in your table you will need to change this into SI units. You can see always there is a value in here, the unit, and then value and SI units. So what we will do, volume of gas, I normally do like a specific number of divisions, like let's say 10 divisions. So I prepare my stopwatch, and whenever this meter is going to get to any of these larger divisions, like 10, 20, 0, 50, 80, any one of them, I'm going to start with recording the time. Then, after a certain amount burns, I will record the time and the volume. I'll show you how this goes. So as I reach 100, I'm going to start with time. Here we go. So time is recorded now, and I'm going to keep recording time for this 10 divisions in here. Now as the flow goes faster, this will start to move much faster also. So you might take more than 10, 20, 30, 40 or whatever. It doesn't really matter, because we are taking volume, we are taking time, then we divide them to get a flow rate. So it should not be really 10. It can be 20, 30, 5, 7, any number you wish. So here we go. We are almost at 8 now. Then we get to 9 and 10. So you will need to look to this horizontally. So here we go. We got 10 divisions of 1/12 cubic foot. So basically is 1/12 cubic foot divided by 10, and this is the time. So volume of gas will go into there, and this time will go in here, elapsed time. Gauge pressure is going to be this gauge pressure. This is the only pressure gauge we have on the system, which is basically telling us the gas pressure going to the burners. So this is the gauge pressure. Absolute pressure will be given to you, which it depends really on the weather outside. Inlet temperature and exhaust temperature. These are the only temperatures related to gas. Inlet temperature is the temperature of gas going to the burner, which is basically, we got it from this here, which is again the room temperature. This is the temperature of gas before burning it as it goes to the burner. Exhaust temperature, as I mentioned, is this thermometer in here, and it is connected to one of these exhaust holes. So this is the only thermometer which is not fixed into the device, because the other two are for water. This is the exhaust gas. Now the next two, which is corrected volume and volume flow rate, these are calculated values which you will need to calculate yourself. Now we will come to the cooling water part. A cooling water is the water flowing in the device in here. So the inlet of water in here goes in, as I said, and the coil get heated up and leave from here. Water inlet temperature is from here, which is obviously, you can see this is the inlet and this is the temperature connected to that. So this is the inlet temperature and this is the outlet temperature. This is the water coming out and this will be the outlet temperature. Now we will need to collect some water in here and again record the time required for that using the stopwatch. So let me show you that. I'll just empty this. So we'll place this here just below this outlet, and we are going to collect some water. Before doing that, we'll need to zero the stopwatch, and at the moment we start collecting water, we need to start with the time. Now, similar to the gas, it doesn't really matter how much volume we collect or how much time we wait, because we are going to divide these two and get the flow rate. At any certain time you wish, or whenever it reaches a certain division you can read, we can stop collecting water and at the same time stop the time. Now we'll leave this little bit to settle so we can read it, which reads about 600 milliliter now, and we record the time, which is 1 minute 15 seconds 69. So now, if we get back to your result sheet, we got the volume of coolant, which is this volume, the water in there, and we got the time from the stopwatch. The mass collected, mass flow rate are values you will need to calculate based on the volume. Temperature in, temperature out are the temperature from these thermometers, temperature in there, and temperature out here. Specific heat capacity, this is value, you can find it in your references, specific heat capacity of water. Then heat transfer per second is something you will need to calculate. Condensate part in here, this relates to that small beaker in there, which I showed you. There is a condensate storage inside, and we will need, similarly, if we have really condensate, we can do again, collect a certain volume and we note down the time, then we fill out on these. But while you are doing this lab, and because most of these lab sessions are limited to 1 hour, you are not going to get any condensate. So if you read through to your sheet, you will find out what to do or what does that really mean if no have condensate. If you want to get condensate, then that will mean running this for a long time. Condensate will start to build up in there, fill the storage till it start and leave and fill the beaker. Now by now, we have pulled one sheet or we have done one test. In your lab, you will need to fill 2 of these. So you will need to do 2 tests. What's different with the other test, or test number 2, is basically the flow rate of gas. We can change the flow from this valve here. And as we open, we can see this will change. So this is moving up. More pressure in there means more flow rate of gas. That more flow rate is going to increase the temperature of gas there. Or, sorry, the temperature of the outlet water. Now, if we give this a few seconds, we can notice the temperature is rising. It's not clear in this video, but while you are doing the lab, it should be fine. So by now, you should know exactly what to do while doing this experiment. Now, if you are done with the experiment, you will need to make sure to close the gas in here, to close this valve, and after a while, after all this cools down, you can close the water. Now, safety instructions, which relates to that lab, as I mentioned before, safety is first, but I keep it last in these videos so it stays in your mind and you can remember it easily. Now, this experiment deals with burners, fire, heat. So you should be careful. Be careful from the outlet water, it can get really hot. And be careful from flammables and open fire. You've got a small fire extinguisher in here, which you can use it only if you are trained or you know how to use it. Don't take any risk. If you feel there is a problem, if you smell a gas smell, means there is a gas leak, you inform any of the staff. If you find that there is some leak on the oil place, you let us know. If there is water going down the floor, also let us know. And avoid moving this experiment setup. There are many items in there and it could fall down from the table. So these things you need to keep in mind. Also, as usual, safety shoes is required in mechanical engineering lab in here. Remember to wear your safety shoes to come before you come to this lab. But you can watch this video without safety shoes. So I hope you learned something from that, and I hope you will get to learn more during your real lab session. Thank you.